This Antennas and Wave Propagation course cover in-depth knowledge of basic antenna principles, concepts of antenna wave propagation, antenna theory, design, and measurements. Antennas and Wave Propagation course aims providing knowledge of different types of antennas. Knowledge of antenna measurement methods, knowledge of radio wave propagation in atmosphere, learning outcomes. Curriculum content of Antennas and Wave Propagation 1. Fundamental concepts, concept of radiation, physical meaning, potential functions and electromagnetic field, network theorems, radiation pattern, near field and far field regions, basic parameters of antenna, directivity, gain, beam width, effective aperture, polarization, input impedance, radiation efficiency, radiation resistance and efficiency etc., Friis transmission equation, methods of excitation. 2. Radiation from wires and loops, infinitesimal dipole, finite length dipole, dipoles for mobile communication, small circular loop. 3. Aperture antennas, Huygens principle, radiation from rectangular and circular apertures, design considerations, Babinet's principle, radiation from sectoral and pyramidal horns, design concepts, Fourier transformation in aperture antenna. 4. Traveling wave antennas, analysis and design of rhombic antennas and V antenna. 5. Broadband antennas, broadband concept, log periodic antennas, frequency-independent antennas. 6. Reflector antennas, parabolic reflectors and reflector optics. 7. Microstrip antennas, basic characteristics of microstrip antennas, feeding methods, methods of analysis, design of rectangular patch antennas. 8. Antenna measurements, antenna radiation pattern measurements, measurement of antenna beamwidth and gain, polarization measurements. Measurement of radiation resistance, S parameter. 9. Antenna arrays, analysis of uniformly spaced arrays with uniform and non-uniform excitation amplitudes, and extension to planar arrays, binomial arrays. 10. Wave propagation, propagation of radio waves, mode of propagation ground wave propagation attenuation characteristics for ground wave propagation, calculation of field strength at a distance. Skywave propagation, atmospheric effects, the structure of the ionosphere, and its effect on radio waves. Ray path, ionospheric propagation, skip distance, virtual height, critical frequency, MUF, fading, diversity. Space wave propagation, reflection from ground for vertically and horizontally polarized waves. Reflection characteristics of Earth, resultant of the direct and reflected ray at the receiver. Duct propagation, joint to Antennas and Wave Propagation course. What will I learn? On successful completion of the course, students will be able to able to explain the basic concept of antenna B. Able to design the antenna for given application C. Able to characterize and analyze the antenna from antenna parameters.